In the previous video, we had studied about the properties of matter and their measurement, and we focused especially about various physical properties of matter. In this topic, we are going to study about in this video, we are going to be studying about uncertainty in measurement. First of all, what do you think the word uncertainty means? It basically means that something which is not certain, or something which we do not know for sure. So there are two reasons why there is uncertainty in measurement. One is because of the observer, and two is because of the device. Okay, so let's assume there are 3 students, okay, and 3 of them had to measure out 5 ml of a particular solution. But the first student did 5, the second did 5.1, the third did 4.9 ml. So obviously there is an uncertainty because these 2 students have measured the value wrong. So this is because of the observer. The second is the device. So there is certain amount of surety to which the device also work, and beyond that value there might be a slight variation. So when you measure it in an analytical balance, it might have a slight error in it itself. Okay, so this leads to an uncertainty in measurement. So there are 2 reasons, observer and the device. So an experimental value is taken multiple. This is why an experimental value is taken multiple times. So when you do a particular experiment, you'll be taking 3 to 4 values, or rather 5. So the higher number of values, the better, and then you will be taking its average. So this makes sure that the uncertainty because of these 2 cases is slightly reduced. Okay, so that's why when we do an experiment, we take multiple values. Okay, so there are 2 very important topics, or I would say terms, that you need to remember when you're learning uncertainty in measurement. One of them is accuracy. Okay, so instead of telling you the definition first and then us figuring out what the definition means, we will study an example first. Okay, so let's assume a sample has about 5.1 grams of iron. Okay, it has 5.1 gram of iron. Now, one person or one method, either way, okay, 1A reports it as 5.23 and B reports it as 5.45. I say both of them are wrong because here we have not mentioned the units. So when I say just 5.23, it means nothing. So the A mentioned it as 5.23 grams and B mentions it at 5.45 grams. So I will deduct it with the value that is over here, and we get 0.13 over here, and we get 0.35 over here for the second case. So accuracy is the difference between the experimental value and the true value. Okay, so less is the difference between this and this, higher is the accuracy. Okay, so it's obvious that 0.13 is less than 0.35 grams. So the accuracy of A is higher than accuracy of B. For if you haven't understood, again let me repeat. Accuracy is the measure of the experimental value. Over here these 2 are our experimental values, and because you already know that sample has 5.1 grams of iron, 5.1 becomes our true value. So this is the experimental value and this is the true value. So the accuracy is nothing but the subtraction or the difference between this, the experimental value, and the true value. Okay, so this is the accuracy. So less is the difference the lesser is the value, more is the accuracy. So 0.13 is less than 0.35. So this person's method or this person is more accurate than this one. The issue with this particular thing is that not always do we know the true value, right? You can't always assume, fine, we'll know the exact amount of a particular substance. So then you cannot predict a particular method or a person's accuracy. So instead we use another term called as precision. Okay, so precision is the difference between the experimental value minus the arithmetic mean. Okay, so precision is the difference between the experimental value and the arithmetic mean. So closer are the values together, less would be the difference between these two values, and it will be more precise. Okay, to understand the concept of precision and accuracy better, let's take an example. Okay, so here I've given you values given by 4 different students who've performed the same experiment, and the true value is supposed to be 2.00 grams. So this is the true value, and we need to figure out who's accurate and who's precise. To start with, let's first calculate the mean. Okay, so mean of each of these basically, let's assume this is 1, let's say this is A and this is B. So the mean would be A plus B divided by 2 because it's an average. So here the mean for the first set is 1.94. Okay, the next set is 1.99. Okay, the third set is 2, and the fourth set is also 2. Okay, so now the precision is nothing but the experimental value minus the arithmetic mean. So for A and B, so for the first case, these values are going to be, that is experimental minus the arithmetic mean, you will get 0.01. So 1.95 minus 1.94 will give you 0.01. 1.93 minus 1.94 will give you minus 0.01. Similarly, we're going to be doing it for the next one. So 1.94 is going to give us minus 0.05, and 2.05 is giving us 0.06. 1.97 and 2.03 will be giving us minus 0.03 and plus 0.03, and the last set is giving us again 0.01 and minus 0.01. So in these values, if you notice, student A and student D have the least difference with respect to the mean. This value is very less compared to the others, which means that these two students are, the values of these students are precise, but B and C are not precise because they have a huge difference between the experimental value and the arithmetic mean. The second is the accuracy. So student A, let's take these values and compare them with this. So of course there's a huge difference between them, because of which student A is not accurate. So his or her values, are not accurate. Next, student B, the difference between this and this is very high, making their value not accurate. Whereas in the third case, it is slightly accurate because they are closer. Not only that, their mean is quite low, is actually the true value. So we'll take them as slightly accurate. Whereas the fourth student has almost just 0.01 difference. So they are, or he, she, that student is accurate. So accuracy is nothing but the difference between the measurement and the actual value, whereas precision is the variation of the same value with respect to the arithmetic mean. With this, we finish this topic. Do check out the next one, which is going to be about the scientific notation.